Good morning, students. Today we are going to see octahedral complexes with D1, D2 and D3 configuration. D1, D2 and D3 configuration always give inner orbital complexes. Just see the example of TF6 3 minus. The atomic number of titanium is 22. That's why its electronic configuration is written as 3d2 4s2. In this complex, oxidation number of titanium is 3 plus. So that's why electronic configuration of titanium 3 plus is 3d1. Titanium 3 plus ion undergoes hybridization, that is D2sp3 hybridization. Just see here, 2d orbital is coming from inner shell. That's why it is the example of inner orbital complexes with D1 configuration. So basically, when D2sp3 hybridization takes place, 6 orbitals of equivalent energy are formed. And just in next step, we show that 6 ligand, that is your fluorine, gives their electronic pair to in each orbital, which is shown by cross. So basically, titanium F6 is octahedral complex because frequency is 6. Now it is important that during this electronic configuration we clear cut see that there is one unpaired electron present in 3d orbital. It simply means that TiF6 3 minus is weakly paramagnetic in nature. Now we are going to see electronic configuration, that is D2 configuration. Example is titanium H2O by 6 2 plus. The atomic number of titanium is 22. Electronic configuration is written as 3d2 4s2. In this complex, your titanium is basically present in 2 plus state. That's why electronic configuration is written as 3d2 4s0. In this complex also, D2sp3 hybridization taking place. Because of that, there are 6 equivalent orbitals in energy are formed. So, in this case, your water ligand, which is neutral in nature, give its electron pair through oxygen. Electron pair is present on oxygen. So that's why oxygen going to give electron pair in each orbital. Since there are 6 water molecules, 6 coordinate bond is formed. In this case, we clear cut see that there are 2 electrons which are unpaired are present in your 3d orbital. That's why TiH2O by 6 2 plus is also paramagnetic in nature. Now we are going to see the example of D3 configuration, that is Cr NH3 by 6 3 plus. We know that chromium have atomic number 24 and its electronic configuration is written as 3d4 4s2. In this complex, your chromium is basically present in 3 plus oxidation state. That's why it is written as 3d3. So in this case also, this 2 orbital from your 3d shell, 1 4s orbital and 3 4p orbitals are undergoing hybridization to give D2sp3 hybridization. So basically we got 6 orbital in equivalent, which are equivalent in energy. So in this orbital, 6 orbital, just count the number 1, 2, 3, 4, 5, 6. In this hybrid orbital, your ligand, that is ammonia, going to give their electronic pairs. Since there are 6 ammonia present, 6 coordinate bond is formed. So donation of electron pair, the electron pair which is donated by ammonia ligand is shown by double X in each orbital. So in this electronic configuration, we clear cut see that there are 3 unpaired electrons present in 3 d orbitals. So this complex is also paramagnetic in nature. Since it have ligand C6, it is octahedral in geometry. Now we are going to see complexes with D4, D5, D6 configuration. Student should note it. This statement, it is very important statement. D4, D5, D6 configuration with strong ligand going to form inner orbital complexes with D2 sp3 hybridization. D4, D5, D6 configuration with a weak ligand going to form outer orbital complexes in which hybridization is sp3 type, sp3d2 type. So first we are going to see examples of inner orbital complexes with D4 configuration. So just see here, MnCn6, MnCn by 6, 3 minus. In this example, central metal atom is manganese. Atomic number of manganese is 25. So it is written as 3d5, 4s2. Now it is in this complex, your manganese is present in 3 plus oxidation state. So electronic configuration is written as 3d4, 4s0. Now just see your ligand, that is cyanide ligand, is a strong ligand. Because of this, pairing effect is occur. So in these complexes, basically D2sp3 hybridization going to take place. So 2 orbital from your 3D shell is used in hybridization. So 6 orbital of equivalent energy is formed. So now just see what is the effect of Cn in your electronic configuration. Since 2 orbitals are used in a hybridization, we have 3 orbital and 4 electron, and because of Cn is strong ligand, pairing effect is occur. So we have to write 4 electron in 3 orbitals. So 1, 2, 3 and then pairing. It is the effect of Cn. In hybrid orbital, your each cyanide ligand going to give their electron pair and going to form coordinate bond. So in this case, in this complex, we also see that there are 2 electrons which are unpaired, and that's why this complex is also paramagnetic in nature. And since 2 orbital from your inner shell, that is 3D shell, is used in hybridization, that's why it is the example of your inner orbital complex. Now we are going to see for D5 configuration, example is FnCn6, FnCn by 6, 3 minus. atomic number of iron is 26. Its electronic configuration is written as 3d6 4s2. In this complex, your iron present in 3 plus oxidation state. That's why electronic configuration is written as 3d5. Now, cyanide is a strong ligand. Because of that, inertial orbitals are used for hybridization. So in this case also 2 orbital from your 3D cell is used in hybridization. So now in this case we have 3 orbital 1, 2, 3 and 5 electron, and because of that pairing going to be happen. We fill electron like this 1, 2, 3, 4 and 5. Why this is happen? It is the effect of strong ligand. Up in hybrid orbital, your cyanide ligand, 6 cyanide ligand donated their electron pair and going to form coordinate bond. So since there are 6 cyanide ligands, 6 coordinate bonds are going to be formed. In this example, we see that there is one electron which is unpaired. That's why it is weakly paramagnetic complex. Geometry is octahedral since ligancy is 6. Now we are going to see D6 configuration. Example is COCN6. COCN by 6, 3 minus. In this complex, just see cyanide is a strong ligand. Atomic number of your cobalt is 27. Electronic configuration is 3d7 4s2. In this complex, your cobalt is present in 3 plus oxidation state. So electronic configuration is written as 3d6 4s0. Since cyanide is a strong ligand, inner orbitals are used in a hybridization. So D2sp3 hybridization is going to take place in your central metal atom, that is cobalt. When 2 orbitals from inner shell are used, we have a condition 3 orbitals and total 6 electrons. So we are going to fill this like this 1, 2, 3, 4, 5, 6. It is the effect of strong ligand. So now just see, we have 6 hybrid orbital and 6 cyanide ligand. Each ligand gives its electronic pair in hybrid orbital and going to form 6 coordinate bond. In this example, we clear-cut see that there is no unpaired electron, and that's why this complex is diamagnetic in nature. Other example of this type of complexes are CONH3 by 6 3 plus, COH2O by 6 3 plus. They have D6 configuration. Now we are going to see outer orbital complexes which have sp3 D2 type of hybridization. So just see the complex CrH2O by 6 2 plus. In this complex, atomic number of your chromium is 24. Electronic configuration can be written as 3d4 4s2. In this complex, chromium is present in 2 plus oxidation state. Since water is a weak ligand, and because of that outer orbital complex is formed. So this d orbital from inner shell is not used in a hybridization. outer shell orbital is used. Outer orbital is used in hybridization. So sp3d2, same orbital, d orbital from same shell is used in this hybridization, not inner shell d orbital is used. So in this case also we got 6 hybrid orbital, and we have 6 neutral ligand, that is aqua ligand. They donate their electron pair and form 6 coordinate bonds. In this example, we clear cut see that your CrH2O by 6 2 plus have 4 unpaired electron. So it is the type of high spin complex, and it is paramagnetic in nature also. For D5 configuration, we have example of FeF6 3 minus. Electronic configuration of iron that have atomic number 26 is written as 3d6 4s2. In this complex, your iron is present in 3 plus state. So electronic configuration for iron 3 plus is written as 3d5 4s0. Since halides are weak ligand, it going to be form sp3 do it going to hybridization should be sp3d2. So there are 6 hybrid orbital is formed, and each ligand donates their electron pair in hybrid orbitals. In this case also we see that there are 5 unpaired electrons are present. So this complex is also high spin complex, and it is highly paramagnetic in nature. So now we are going to see for D6 configuration. Example is FeNH3 by 6 2 plus. Electronic configuration of iron is written as 3d6 4s2. In this example, your iron is basically present in 2 plus oxidation state. So electronic configuration of Fe2 plus is written as 3d6 4s0. Since your amine is weak ligand, it is going to be a form sp3d2 hybridization. So in this hybridization, all orbitals belongs to same shell. So in this complex, 6 amine ligand donates their electron pair to 6 hybrid orbitals and going to form 6 coordinate bond with your iron. So in this complex also, in electronic configuration, we clear cut see that there are 4 unpaired electrons are present. So it is the type of high spin complex, and it is also paramagnetic in nature. Some other example of these types are FeH2O by 6 2 plus, CO Fe6 3 minus. Now we are going to see complexes with D7, D8, D9 and D10 configuration. D7, D8, D9, D10 configuration always forms your outer complexes. It is important. They always form outer orbital complexes. So we are going to see example of D7 configuration. Example is COH2O by 6 2 plus. Atomic number of cobalt is 27. Electronic configuration is written as 3d7 4s2. In this complex, your cobalt is present in 2 plus oxidation state. So electronic configuration of cobalt is written as 3d7 4s0. Since it is a weak ligand with a D7 electronic configuration, hybridization is sp3d2. So in this 6 hybrid orbital, your 6 water ligand donated their electron pair and going to be formed 6 coordinate bond. In this example also we see that there are 3 unpaired electrons. It is the example of high spin complex and it is paramagnetic in nature. Other examples of this type is CONH3 6, CONH3 by 6 2 plus. Now we are going to see D8 configuration. Example is NiNH3 by 6 2 plus. Atomic number of nickel is 28. So electronic configuration is 3D8 4s2. In this complex your nickel is present in 2 plus state. So electronic configuration of Ni2 plus ion is 3D8 4s0. It undergoing sp3d2 hybridization. And in every hybrid orbital your ammonia ligand donate 1 electron pair. So 6 ammonia ligand, 6 hybrid orbital. It simply means that 6 coordinate bond. In this electronic configuration we see that there is unpaired electron present in your 3D orbital. That's why this complex is also paramagnetic. Now we are going to see D9 configuration. Example is copper H2O by 6 2 plus. Atomic number of copper is 29. So electronic configuration is written 3D9 4s2. In this complex your copper is present in 2 plus state. Electronic configuration is write as 3D9. Since water is weak ligand, sp3d2 type of hybridization is favored. So 6 hybrid orbital, 6 ligand, and there are 6 water ligand is present. So 6 coordinate bond is formed. In this example also we see that there is 1 unpaired electron. So this complex is also paramagnetic in nature. Now we are going to see for D10 configuration. Example is zinc NH3 by 6 2 plus. Electronic configuration is 3D10 4s2 for zinc. But in this complex your zinc is present in 2 plus oxidation state. Electronic configuration is 3D10 4s0. Since your ammonia is weak ligand, it is going to be form sp3d2 type of configuration. So 6 hybrid orbital, 6 ligand, each ligand donates its electron pair to hybrid orbitals and going to form 6 coordinate bond. In this example we clear cut see that there is no unpaired of electron. So it is dimagnetic complex. Geometry is octahedral because it have ligand C6. In our next class we are going to see complexes with coordination number 4. Thank you very much.